Ever wonder why your phone, your car, or even, that complex medical device just works?
Hmm.
No weird static, no random glitches, no signals getting crossed.
Right, you just expect it to function smoothly.
Exactly. Well, you're experiencing the magic of something called EMC filters. Think of them as like the unseen traffic cops of the electronic world.
Keeping everything flowing, preventing digital pileups.
Precisely. They keep signals clean and stop interference. So today, we're doing a deep dive into the EMMC Filters Market. We're exploring how these absolutely essential components ensure everything from your tiniest gadget to huge industrial systems stay compliant and, well, just work properly.
It's a critical piece of the puzzle.
It really is. Our mission today is to pull out the key insights from a recent market report. We're looking at performance back from 2021, some projections for 2025, and then a longer view looking out all the way to 2033.
Quite a time frame.
Yeah. And just to give you a sense of scale right off the bat, this market was already pulling in over $1.1 billion in 2021.
Wow. Oh,
And that's set to climb to nearly $1.4 billion by 2025. Then looking further out, it's expected to surge past $2 billion by 2033. So it's expanding at a pretty steady annual rate, almost 5%.
you know what's truly fascinating here isn't just the sheer size of those numbers, though they are impressive. It's what they actually represent for our world, which is becoming more and more connected, more automated.
Right.
These filters, these EMI things, they're basically the bedrock tech stopping electronic interference. Without these digital traffic cops, like you said, your smart devices, medical gear, even the critical systems running our cities, they just couldn't function reliably. So the steady, strong growth in this market, it directly mirrors how much we rely on electronics now and how much we demand, perfect performance.
Okay, so let's unpack this a bit more then.
Yeah.
We mentioned those big global growth figures, that clear, consistent upward trend. If the market's booming like this, what are the main reasons? What's driving this growth across, well, pretty much everywhere?
Well, connecting this to the bigger picture, the report points to basically three powerful drivers. First, there's this growing absolute necessity for electromagnetic compatibility EMC in every electronic device.
Okay.
As we fill our lives with more gadgets, wearables, smart homes, you name it, the chance they'll interfere with each other just skyrockets. So filters become, non-negotiable.
Makes sense. More devices, more potential noise.
Exactly. Second, there's the huge rise of industrial automation. Picture a massive factory floor, robots, complex machines all working together.
Uh-huh.
The sheer complexity demands perfectly clean signals. It's about safety, precision, efficiency.
Right. Can't have a robot arm glitching out.
Definitely not. And third, and this is a big one, increasingly strict regulatory requirements, especially in vital sectors, think telecom, automotive, aerospace.
Right.
Regulators are tightening the standards.
Why is that?
Well, partly for safety, of course, but also to make sure these complex systems don't accidentally mess with other critical things like, say, air traffic control or emergency communications.
Ah, okay. So it's about preventing wider disruption, too.
Precisely. Compliance is key.
Now, here's where it gets really interesting, I think.
Mm.
When you look at where this growth is hottest, Asia-Pacific is clearly leading the global charge.
Oh, absolutely.
This region has the highest regional growth rate, the CAGR, at over 5.6%. We're talking about a market that's already grown a lot and is projected to hit almost $780 million by 2033.
It really is the epicenter of this expansion. And if you dig into the specific countries within Asia-Pacific, China is, well, it's the dominant force in just sheer market size. It's projected to almost double its contribution by 2033.
Wow.
But it's really stand out? India. India actually has the highest individual growth rate, the highest CAGR in the whole report, a remarkable 6.566%.
Over 6.5%. That's huge. What does that signal?
Well, it strongly suggests, a really rapid acceleration in their domestic electronics manufacturing and consumption, maybe mirroring its broader economic boom.
Interesting. And the others in the region?
Japan and South Korea are still very strong, sort of mature contributors, continuing steady growth. And then you see this really fast-paced development across Southeast Asia. Singapore's doing well too, Australia, Taiwan. They're all showing really promising momentum.
So it's widespread growth within APAC.
Yeah, it really highlights how vital this filter tech is becoming for both developing and developed economies over there.
Okay, let's shift gears slightly. Let's turn to North America. Now, Asia-Pacific is leading in growth rate and sheer numbers, but North America has its own compelling story, right?
Yeah, that's right.
It started at over $336 million back in 2021, and it's projected to grow quite a bit. nearing $563 million by 2033. That's a solid annual growth rate, too, almost 4.4%.
That's right. And within North America, the United States, maybe unsurprisingly, leads in the overall market size. It's poised for pretty significant expansion, projected to reach over $450 million itself.
Okay.
What's kind of interesting, though, is that Canada's market is actually growing a bit faster. Its CAGR is over 5.1%.
Higher than the U.S.
Yeah, higher growth rate. It's a smaller market overall, obviously, but its trajectory is quite sharp. And Mexico also shows healthy progress, steadily increasing its share.
So even if the total numbers aren't as massive as Asia-Pacific, the growth is definitely there across the board in North America.
Exactly. It shows that the understanding of needing this electromagnetic compatibility, it's widespread.
Now, over to Europe. Europe also makes a significant contribution to the global market. The region generated almost $246 million in 2021, and it's estimated to reach over $415 million by 2033. That's expanding at about 4.5% annually.
Yep, another solid contributor. In Europe, Germany really leads the pack. Strong, consistent growth there, projected to hit around $90 million by 2033, with a CAGR over 5.2%.
Germany leading. That makes sense given their industrial base.
It does. The UK is also a very significant player, still growing steadily. France and Italy, too, both contributing substantial market value. Spain is showing robust movement as well, with the KGR close to 5%.
And the rest of Europe.
Yeah, what's notable is that the rest of Europe, which is, a collection of many diverse economies, collectively shows strong upward movement. It indicates really widespread adoption across the continent.
Which probably ties back to that regulatory point you made earlier. Europe's known for strong regulations.
Absolutely. That and their focus on high-quality industrial applications, it really drives demand for reliable components like these filters.
So we've covered Asia-Pacific, North America, Europe. What does this all mean for other parts of the world? It's not just the major economic blocks seeing this growth, is it? Is this tech becoming truly, globally essential?
Oh, absolutely. That's one of the key takeaways, I think. The growth is incredibly broad-based. Take South America, for instance. Their market is projected to nearly double by 2033.
Doubling.
Yeah, with countries like Brazil, Argentina, Colombia showing particular highlights. Then you look at the Middle East, strong expansion there too. Saudi Arabia leads overall, but the UAE really stands out.
UAE? How so?
Their KGR is impressive, nearly 6%. So very rapid growth. You could probably link that to their big smart city projects and efforts to diversify their economy with tech.
That makes sense. And Africa.
Africa, yeah, it's starting from a smaller base, naturally, but it's also poised for significant growth through 2033, expected to hit nearly $77 million, with South Africa leading that charge.
Okay, so it really is everywhere.
It really is. And this raises, I think, an important question. This broad base of growth in such a foundational technology like EMC filters, what does it imply for global tech development, for interconnectedness? It just highlights how essential these traffic cops are becoming for, everyone, everywhere, as we build this increasingly electronic future.
Right. So to kind of synthesize all of this, it's crystal clear the EMC filters market is seeing significant, truly global expansion.
Undeniably.
And the driving forces seem consistent everywhere.
Yeah.
That absolute need for electromagnetic compatibility as devices multiply.
Yep, the non-negotiable part.
The relentless march of industrial automation.
Can't stop that train.
And those ever-tightening rules and regulations in key sectors like telecom, auto, aerospace. It really is a foundational technology, just silently underpinning, our entire modern world.
It really is. And, thinking about that, if these filters are so critical right now for stopping interference and ensuring compliance, what happens next? What unexpected advancements or maybe challenges might pop up as devices get even smaller, more numerous, more integrated into everything around us?
Good question.
And how might that ongoing evolution of digital traffic actually shape the products that you use every single day? Something to think about. Welcome to the Deep Dive. Today we're pulling back the curtain on some really unseen heroes in our modern world. We're talking about a component, it's tiny, but it's vital. It's quietly safeguarding pretty much every electronic device you use.
Yeah, almost everything.
I mean, imagine a world where, say, your smartphone suddenly starts messing with your smart thermostat at home.
Right.
Or maybe your car's safety systems, the really critical ones, they start glitching out just because of some stray electronic signals. What if the stuff we rely on just stopped working right?
It's a genuinely unsettling thought, isn't it? And that kind of electronic chaos, that potential mess, that's exactly what our topic today prevents.
Okay.
We're diving deep into EMI filters.
Right.
These are the crucial bits, the components, making sure everything works smoothly, safely, and meets all the rules. They manage electromagnetic interference, EMI.
Got it. So our mission today for this deep dive is really to dig into what's shaping the market for these filters. We want to get why they're becoming so important, what the big challenges are in, making them and getting them adopted. And, of course, what cool new things are happening, the future trends.
Sort of understanding the silent guardians of our super connected world.
Yeah, exactly. The silent guardians. So how did they get so, indispensable? Where did this massive need come from?
Well, it's not just that devices are complex now. That's part of it, sure. But it's how they all interact, that interdependence that's created this whole new level of vulnerability, electromagnetically speaking.
Okay.
Think about the complexity inside, say, our smartphones or smart home gadgets, industrial controls, even medical gear. They're shrinking, right? More and more stuff packed in.
Miniaturization, yeah.
And that creates these, well, we call them electronically dense ecosystems. Lots of components really close together. They become super susceptible to EMI. So filters, they're kind of like unseen air traffic controllers for signals, making sure everything flows right, signal integrity, device function. Without them, it'd just be electronic noise, a real mess.
That makes sense, just the density alone. And I guess on top of that complexity, the rule books must be getting thicker too. Regulations have got to be playing a huge part here.
Oh, absolutely. A huge part. And what's really insightful about the regulations isn't just that they exist, it's how they've basically forced manufacturers to design for compliance right from the start.
So it's not an afterthought anymore.
Not at all.
Yeah.
We're talking globally enforced standards, things like the FCC rules in the U.S., CSPR internationally, even specific military ones like MIL-STD.
Right.
And sticking to these, it's not just, a good idea. It's non-negotiable if you want your device to work safely, compatibly.
Yeah.
Without messing up other equipment or getting messed up itself.
Okay.
So filters aren't just some add-on part. They're fundamental to even getting a product onto the market anywhere in the world.
So it's not just about what your device can do, but critically what it must not do to everything else around it. And speaking of things that absolutely must not go wrong, electric vehicles. The growth there is explosive, and the amount of electronics packed into cars now.
Oh, yeah.
Cars today are basically computers on wheels. That seems like a massive driver for these filters.
It really is. I mean, regulations are one thing, but just the sheer volume of electronics in cars now adds a whole other layer. Modern cars, they're loaded with safety-critical systems. You've got ADAS, the advanced driver assistance systems, the tech that helps park the car or keeps it in lane.
Right, lane assist, emergency braking.
Exactly, all that. Plus infotainment systems that powertrain controls, all highly vulnerable to EMI.
Right.
Filters make sure these systems keep running without disruption. They're absolutely indispensable in this whole shift towards electric mobility. You just can't risk, say, a self-driving car's sensors getting scrambled by some random electromagnetic pulse.
No, definitely not. Okay, so the demand is crystal clear. But making these little protectors, it sounds like it's not exactly simple. What are some of the biggest headaches, the engineering challenges that manufacturers are dealing with?
Well, one pretty significant hurdle is just the cost, especially for the advanced filter designs. Basic filters, they can be pretty cost effective. But the high-end ones, the types used in really demanding areas like aerospace, military applications, some industrial settings, they come with a much higher price tag.
Why is that?
It's down to the precision engineering needed and often premium materials too. This higher cost, it can genuinely be a barrier to adoption, especially in markets that are really sensitive to price. Unless, of course, the regulations specifically demand that level of performance.
Right.
You really have to weigh the cost of that filter against the potential cost, the real cost, of a system failing if you don't put it in something critical.
And talking about precision engineering, trying to squeeze these high-performance components into devices that just keep getting smaller and smaller, that must be a nightmare. Size constraints have got to be a constant battle.
It is. It's a constant tug of war for the engineers.
I bet.
As consumer gadgets, wearables, medical implants, as they all keep shrinking, fitting in an EMI filter that actually performs well within that tiny space, it gets incredibly difficult.
Oh, it gives.
Well, engineers often face this compromise, this trade-off between the filter's performance, how much heat it might generate or need to dissipate, that's thermal management, and just the physical compactness.
Ah, okay.
It's like a real engineering trilemma,
Yeah.
balancing those three things. And sometimes it affects the overall feasibility of the device design itself. You
Yeah,
can't
yeah.
just shrink a filter indefinitely without hitting its performance or maybe making the device run too hot.
It really does sound like this sort of secret world of components working away behind the scenes,
Yeah.
which maybe leads to another challenge you mentioned, low awareness, especially in, say, less technical areas. I mean, honestly, who thinks about EMI filters until maybe their Wi-Fi drops out when the microwave is on or some device just starts acting weirdly?
You've absolutely hit on a crucial point there.
Yeah.
In places where maybe the regulations aren't enforced quite as strictly, or maybe among smaller manufacturers who don't have huge compliance teams,
Yeah.
the actual importance of good EMI filtering, it's often really underappreciated.
So they might skip it or use a cheaper, less effective one.
Exactly. And that leads to missed opportunities for adopting the right filter for the job, even while the background level of electronic noise and potential interference keeps going up. It's a bit like the classic case of not knowing you have a problem until something actually breaks down.
Like forgetting to check the oil in your car until the engine light comes on.
Precisely. The problem is silent, invisible, until suddenly it's not, until it causes a real malfunction, maybe even a catastrophic one.
Okay, so despite these hurdles, the cost, the size, the awareness gap, it sounds like, innovation in this space is actually picking up speed. What are some of the really exciting trends shaping the future here? You mentioned clean energy earlier.
Yes, that's a great place to look because filters are becoming increasingly vital in renewable energy and power electronics generally.
How so?
Well, think about systems like solar inverters, wind turbines, battery storage systems. They all operate using high switching frequencies.
Okay, what does that mean exactly? High switching frequencies.
Think of it like electricity being switched on and off incredibly rapidly, thousands, maybe millions of times per second, to control power flow efficiently.
Ah, right?
But that very rapid switching, it inherently generates a lot of electromagnetic noise EMI.
Okay.
So filters are now absolutely essential for maintaining performance stability in these clean energy systems. They help ensure the grid stays reliable and stable as we add more and more renewables.
That's fascinating. So they're enabling the green transition too, in a way.
In a very real, practical way, yeah.
And it sounds like the filters themselves are evolving. You mentioned integrated and modular solutions. Does that mean no more fiddling with tiny individual components on a board?
That's the direction things are moving in, yes. These are sort of next-gen products. They often offer like plug-and-play installation,
Nice.
which naturally saves valuable space on the circuit board.
Yeah.
And it really simplifies the overall design process for engineers.
So faster design cycles, maybe? Easier integration?
Potentially, yes.
Yeah.
It makes them really well suited for electronics that need to be compact but also high performance. We're seeing a whole range from tiny board level modules right up to filters integrated into the actual device enclosure. It's definitely modernizing how we handle EMI filtering, making it more efficient, maybe more user-friendly for designers too.
Like going from building your own complex desktop PC from parts to just getting a sleek, integrated laptop?
That's actually a pretty good analogy, yeah.
Okay, and then for the really high-stakes stuff, aerospace, defense, critical healthcare applications where any interference could be just disastrous. You mentioned multi-stage filters are becoming more common. What makes them so special?
Right. When you're in a situation where even the tiniest bit of interference could compromise safety or mission success or regulatory compliance, the level of protection you need becomes, well, non-negotiable.
Makes sense.
Multi-stage filters, they are more advanced designs. They typically offer superior suppression, better filtering across a wider range of frequencies. And crucially, they tackle both types of noise, effectively differential noise, which is noise on the signal lines themselves,
Okay.
and common mode noise, which is like unwanted interference that appears on multiple lines simultaneously relative to ground.
Ah, got it. So they clean up everything.
They provide a much more robust, comprehensive cleanup, yes. So in those high-stakes sectors, aerospace, defense, critical medical equipment where failure is simply not an option, these multi-stage filters are rapidly becoming the gold standard. They offer that ultimate layer of reliability assurance.
Wow. Okay, so if we try and synthesize everything we've talked about in this deep dive today, it seems really clear that as our world gets more connected, more electrified, definitely more performance-driven, The importance of these EMC filters is just going to keep climbing.
Absolutely.
Yeah.
They truly are the unsung guardians, aren't they? Ensuring device reliability, safety.
Yeah.
They're quietly impacting pretty much everything, from the EVs we're starting to drive to the renewable energy systems powering our grid, even down to the incredibly precise medical instruments used in hospitals.
Their work is often invisible, yeah, but clearly vital.
Utterly vital.
It really makes you wonder, doesn't it, when you stop and consider just how many essential functions in our modern lives are quietly enabled by these hidden components.
Hmm.
What new challenges, or maybe even surprising new applications, are going to demand even more advanced filtering solutions in the near future? Where are the boundaries going to be pushed next for these tiny guardians? We'll leave you with that thought.